Okay, so we continue looking at uncertainty in measurement. So you remember from the previous video, I showed us these four equipments. There was a graduated cylinder, there was the pipette, burette, and the volumetric flasks. Now, when we talk about uncertainty, it's very, very important because every time when we're taking measurements, we're talking about quantitative analysis. So, meaning that we are always measuring things. And it's so common when we are measuring the volume of a substance that we are always going to get some uncertainty. So, let's just dive into this example and see what we are talking about. So remember now here what we're trying to do is that we're trying to measure the mass of rather the volume of a particular fluid. Now the key thing here is that the volume is going to be read at the bottom of the liquid cave, or what we call the meniscus. So you see that on those, so we are focusing on the diagram that's on the left. Okay, so now you see that meniscus, it's like, okay, so on either sides it's up, then it goes down. So when you're taking your measurements, you use that bottom part, or the bottom part of the meniscus. Now you will realize that if we got 5 people and told them to say, okay, give us the volume of this particular fluid to 4 significant figures, you will realize that people come up with different values, as you can see in that table. So there will be someone that will approximate it to that degree. People will be using different approximations. Now you will realize how this particular burette is graduated, and you will realize that between between, or rather let's say between 20 and 21, you realize that they are it's been divided into parts which are almost equal to 10, isn't it? So that means that since between one unit, or from 20 to 21, there are 10 graduations. So that basically means that each particular part is going to be 0.1, 0.2, just like that. Makes sense, right? So it means that that first line below the 20, that should be 20.1. Then the other one, 20.2, just like that, right? It makes sense, isn't it? So now what we are having here is that this meniscus, it's between what? It's between 20.1 and 20.2. So now that's why you see that the people that we are looking at these values, they are giving us what? You realize something that is interesting here. All the values that they are giving us, you realize that the first 3 numbers are the same. So the 20 is definite, is the same, and then the 1 as well is definite. But then where people are differing is where it's on the last digit. Why are they differing? Because for the last digit, it's just a matter of approximations, right? Nobody is certain. Nobody can tell the other that this is the thing, this is that. But one thing for sure is that we know that 20 is certain, and the point 1, okay, the 0.1, that's certain as well. So you will realize that the first 3 digits are what we call certain digits. Okay, certain digits, because no matter who we ask to say give us the reading of this, they will get the first 3 numbers correctly, so long as they understand how the divisions have been made between the graduations. Okay, so 20.1, almost each and every person, regardless of who makes the measurements, those 3 digits will be the same. Okay, and so we call those the certain digits. However, you realize that the fourth one, it's going to be different depending on who that particular person is, and you can't blame anyone because everyone is just trying to approximate. So what does this then tell us? It tells us that that fourth digit, it's what we call okay, that's now what we call the uh, uncertain digit. Uncertain digits, because it's going to change, okay, depending on who reads it. So it's very, very important to understand that a measurement always has some degree of uncertainty. So this means that basically no matter what we are trying to measure, there's always going to be some degree of what? Of uncertainty. So let's look at this example that we have in the table there. So you see, there's the grapefruit. The bathroom scale is measuring them both at 1.5. Okay. And then what you're going to see there is that when you look at the balance there, it's more specific, or rather, it's it's more detailed, it's giving a more detailed value, and there you can see the difference. So what this basically means that if you only use the bathroom scale, you would think, oh, okay, you know what, these are the same masses. But then when you use the balance, which is more detailed in terms of the values that it's giving, you realize that actually these are different. Okay, so therefore, can you say that the two grapefruits have the same mass? Well, the answer depends on which set of results you consider. Therefore, we can say a conclusion based on a series of measurements depends on the certainty of those measurements. So, for this reason, it is important to indicate the uncertainty in any measurement. Okay, so you always want to tell people, it's okay, these values that I'm giving you, the certainty that I have is this and that. Perhaps you may have seen some food level labels where they will say maybe 70 kilocalories and then put plus or minus zero point 0.1, right? So they are telling you to say what we measured was this and that, but we know that there could be an error over this margin, so that you are well aware of that. So now, it's very, very important to indicate the uncertainty in any measurement, so that you can imagine people that work in factories, right? You don't want errors of that sort. So people have to plan, people have to have an idea. Say, okay, these values that we've been given, they may be lower or higher than this by this margin, so that they can be able to plan ahead if need be. So to ensure that these degrees of uncertainty are are indicated. This is done by always recording the certain digits and the first uncertain digit, which is the number that you've estimated. So like in our previous example, 20.1, those were certain digits, right? But then, so you record all the certain digits and the first uncertain digit. Why don't you want to record two uncertain digits? Because that wouldn't make sense, right? Because you're saying already the first uncertain digit you are uncertain. Then how can you put another digit which is uncertain? It wouldn't add up, right? So it's the all the certain digits and the first uncertain digit. So these numbers are called significant figures of the measurement. So you can see those examples that I gave there where they're saying 1.86 plus or minus 0.1 kg, so that you are well aware of what you're dealing with. So now let's now look at this concept. So here now, this particular example. So you see uncertainty in measurement. So in analyzing a sample of polluted water, a chemist measured out 12.00 ml water with a pipette, and then and at another point in the analysis, a chemist used a graduated cylinder to measure 25 ml of a solution. What's the difference between the measurements? So here we are trying to assess, right? So when you use a pipette goes into details. It gives you a lot of certainty and a high degree of certainty. So what this basically means is when you look at this from what we've discussed is that remember those four equipments that I showed you. One thing about a pipette is that the pipette is going to give you the value when it says 25.00 milliliter. That's the value it's giving you. It between 24.99 and 25.01 mils. So you can see that it's got a high degree of certainty. But on the other hand, when you look at a graduated cylinder, it's giving you 25 mils, but that means it can be anywhere between 24 and 26. So you see that you would say that the pipette measures volume with a much greater precision than does the graduated cylinder. So that's about uncertainty. So next we'll be looking at precision and accuracy. So you can join me in the next video.